Integration Services has a variety of tools and provides various techniques you can use to see what a task or package is doing and how it's doing it. You can cause the behavior of a task to change when problems arise, whether from bad data or missing resources, and you can partition a control flow so that a whole separate set of tasks execute only when certain kind of events occur, such as problems. You can pause package execution at predefined breakpoints, conceptually similar to breakpoints in programming tools, but quite different in practice. You can cause the package to store information in a checkpoint file about where it failed so that the next time you run the package, it doesn't repeat any tasks that completed successfully. And you can log many kinds of information about the package as each task executes. So that's just a quick overview of the various techniques that you can use in integration services when things go wrong. And so now let's start by talking about one of the more useful techniques you can use, particularly to save time when things do go wrong, and that's called checkpoints. Now, as you learn about integration services, you'll be able to track larger and more complex ETL projects with dozens or even hundreds of tasks moving data among many data stores and performing multiple transformations on it along the way. You may also have individual tasks that take hours to run because of the volume of data that they have to move and process, or because of slow resources such as network speeds. A package might fail after many tasks completed successfully, or after the 1 hours-long tasks complete. If you have to rerun the entire package after fixing the problem, you'll again have to patiently wait for hours while earlier tasks duplicate their work before you even get to the point where the package failed on the first run. That can be a pretty painful experience. And, quite frankly, the local database administrator is likely not going to be very pleased that you're taking up so many resources for so long, repeatedly. To get around these kinds of problems, integration services packages are restartable using a feature called checkpoints. When you implement checkpoints, the package creates a checkpoint file that tracks the execution of the package. As each task completes, integration services write state information to that file, including the current values of variables that are in scope. If the package completes without errors, integration services just deletes that checkpoint file. But if the package fails, the file contains complete information about which tasks completed and which failed, as well as a reference to where the error occurred. After you fix the error in the package, you can execute the package again, and the package restarts at the point of failure, not at the beginning, with the same state it had at failure. So as you can probably guess, checkpoints are an incredibly useful feature, especially in long-running packages. Now, checkpoints are not enabled on a package by default. You have to set 3 package-level properties in order to configure the checkpoints. The first one is checkpoint file name, and this specifies the name and location of the checkpoint file name. You have to set this property, but the name can be any valid Windows file name with any extension. The second property is checkpoint usage. This determines how the package uses the checkpoint file while the package executes, and it has 3 different settings. The first option is always. In this case, the package will always use the checkpoint file and will fail if the file doesn't exist. Second option is if exists. In this case, the package will use the checkpoint file if it exists, in order to restart the package at the previous point of failure. Otherwise, execution begins at the first control flow task. And this is the usual setting that you probably want to use most of the time for checkpoints. And then you can also set it to never. With this, the package will not use the checkpoint file even if it exists. So that means that the package is never going to restart and will only execute from the beginning. So this is a quick and easy way to disable the use of checkpoints as you're developing the package and iteratively executing it. And then the third property is save checkpoints, and this specifies whether the package should write checkpoints to the file. So this combination of 3 properties provides flexibility in configuring checkpoints for the package then turning it on and off before execution without losing the checkpoint configuration, depending on the combination of settings. Now, in order for checkpoints to work, a task failure has to cause the package to fail. Otherwise, the package will continue executing beyond the failure, recording more data in the checkpoint file for subsequent tasks. And for a very robust package, that's generally how you want to design your packages. But you can also use the fail package on failure property to true for each task where you want to make it possible to restart the package using a checkpoint. If that property is set to false for a task and the task fails, Integration Services doesn't write any data to the checkpoint file. Because the checkpoint data is incomplete, the next time you execute the package, it'll start from the beginning. Okay, so this is essentially a way to make things even more granular in your control of checkpoints. And then one thing to note about this is that checkpoints only record data for control flow tasks. This includes a data flow task, but it doesn't save checkpoint data for individual steps in a data flow. So it does it for the overall data flow, but not the individual tasks within the data flow. Therefore, a package can restart at a data flow task, but not within the data flow itself. In other words, you can't restart a package using a checkpoint to execute only part of a data flow, just the entire data flow. Now, at the start of the package, when it starts executing, Integration Services checks for the existence of that checkpoint file. If the file exists, Integration Services scans the contents of the checkpoint file to determine the starting point in the package. And then Integration Services writes to the checkpoint file while the package executes. The contents are stored as XML and include several different pieces of information. First is the package ID. This is just a GUID that's stamped onto the file at the beginning of the execution phase. Execution results. This is a log of each task that executes successfully in order of execution. Based on these results, Integration Services knows where to begin executing the package the next time. And then variable values. Because what Integration Services is doing in order to save state is it's saving the package variables values within the checkpoint file. And then when you restart execution later using that checkpoint file, those variable values are read from the checkpoint file and then set within the package itself. In this exercise, I'm going to create a new package that uses script tasks to manipulate a variable through various steps, and an execute SQL task to perform an illegal operation to make the package fail. And along the way, I'll configure the package to use checkpoints and examine the contents of the checkpoint file. All right, so I'll create my new project. Integration Services project. I'll put in a convenient location, and I'll call it checkpoints. Don't need the getting started information, and as usual, I will change the name of the package to match the name of the project. Certainly not necessary, but works for samples like this. Okay, next thing I want to do is I need to create a variable. So I'll open up the variables window and add a new variable, and I'll call it state. So it's just a demo variable that I'm going to include some sort of state information. And I'll leave the other properties set to their defaults. In particular, it'll have the scope of the package itself, and the data type will be int32. All right, then I'll close that. There's no save function as such on the variables window, so I can just close it. And now we have a package level variable designed. All right, now from the toolbox here, I'm going to add a script task. Just double click on it to add it there. And I'm going to rename this state1. Because as you'll see, I'll take the variable through some states. And so this is just a convenient way of identifying what state we're in at any given point. All right, I'll open up the script task editor. And then within the script in this component, I'm going to modify the value of that state variable. So in order to access that through my code, I need to add it to the list of read-write variables. And the easiest way to do that is just pop up the list. Again, this list doesn't display system variables because no system variables are read-writable. So it's only any user variables that are available. But I also could have typed it in as well. And I'm including the namespace there to eliminate any ambiguity. All right, so I've set everything up, so I'm going to open up the Vista development environment. Okay, I'll hide these windows. And I'm going to modify code here within the main method, which is the entrance point for this class, for the script component. So what I'm going to do here is I'm going to use the DTS object and the variables collection in order to get access to that state variable. And I can do this, I can write this statement of code because I included state as a read-write variable. And I'm going to change the value and I'm going to increment it. So what I'm going to do is read the value, the existing value, using that same variables collection. And I'll add 1 to it. Okay, so again what I'm doing is I'm reading the value of that state variable when this code begins executing, adding 1 to it, and then storing it in that same variable value. So I'm just incrementing the variable value. And then, just to make it easier to see what's going on, I'm also going to display that value. So I'm going to use a message box. And I'm going to display state is equal to, and then once again read the value of that variable, which is going to be its new updated value at this point. And convert it to a string. Let's see, I have a little red squiggly here. Oh, yep, left off parentheses. Okay. All right, so once again, very simple code. And it's just reading the variable, incrementing it, and displaying it. And so, since this is the first time through, state is initially set to 0. This should show a state value of 1. Okay, so I can close the Vista window, and OK. And I'll go ahead and execute the package just to make sure everything's working. It loads it up, and there's the message box saying state is now equal to 1. I'll end execution, and I'll start it up again, and it's still equal to 1. Because state is reset to 0 with each execution. Okay, so far so good. The package is executing just fine. All right, so now I'm going to reuse this component. So I will copy it, and I'll come down here and paste it, and paste it, and paste it. And for good measure, paste it one more time. Okay, so I now have duplicate script tasks that are going to do identical things to that state variable. And to make it clear what's going on, I'll rename these. This I'll name to state 2. This I'll rename to state 3. Of course, it's going to be a very rare package where I'm going to know the state unambiguously enough to name a component after what it should be, but it works in this example. And 5. Okay, then I also want an execute SQL task. So I'll drag that over here. And I actually want this between state 3 and state 4. Because this is the task that is going to cause execution to fail. So I'll double click on this to open up the Execute SQL Task Editor. And then I need to create a connection. And I'll select New Connection there. Now in this particular case, I really don't care what database I use because I'm not going to be executing or accessing data within the database. So I have an existing connection to the AdventureWorks LT 2012 database. I'll just go ahead and use that. But that you need to have some kind of a connection for an Execute SQL task, even if, like this one, the SQL code isn't going to be accessing that data. All right, then I need to enter a SQL statement. I can either enter it directly there, or I can open up the SQL query box. And I'm going to do something not so great. I'm going to divide by 0. Okay, so obviously this statement, when this task executes, is going to cause an error, a problem, because you can't divide by 0. All right, so that's configured. Now we need to wire it all up into precedence. So I'm going to go from state 1 to state 2. State 2 to state 3. State 3 to my Execute SQL task. Execute SQL task to state 4. And state 4 to state 5. And I'll make this a little bit easier to read. Oops. Just want those two. That'll make it a little bit clearer what the flow is. So as you can tell, neatness doesn't count as long as all the precedence operators are there and in the right order and configured correctly. Okay, so I'm going to save the package and execute it again. I get state 1, so far so good, state 2, state 3, and then everything blows up. If I scroll down there a bit, you can see that the Execute SQL task failed, as expected. And if you look at the error down here in the output window, you can see error blah blah blah. Executing the query, select 1 divided by 0, failed with the following error, divide by 0 error encountered. Possible failure reasons, as though that wasn't clear enough. Problems with the query, property not set correctly, parameters not set correctly, or connection not established correctly. So obviously the problem is that first option, problems with the query. Okay, so the package did exactly what we expected. It's working at this point. So I'll end execution, and theoretically I'll now go in, correct any errors that I found, and I'm ready to execute the package again. And so I'll start it, and the package starts over. Okay? So I'm going to go through 3 steps: state equals to 1, state equals to 2, state equals to 3, and it errors again. So the scenario here is that these 3 steps don't take all that long to run. They require some user interaction to get past because I have a message box, obviously not a real common thing you would do in a real package. But what if any of those 3 first tasks took a long time to run? I would get an error in my Execute SQL task here, and I would fix the problem, and maybe it might take several tries to get the error completely fixed, particularly if you're working with importing data and there might be a number of different issues with the data. Then I would have to start the package again, wait for all those to execute for however long they take, and waste a lot of time like that. So that's kind of the scenario that I'm demonstrating here. Okay, I'll end execution. Okay, now one thing to point out here is that if you look at the properties for the Execute SQL task, and specifically you look for the fail package on failure property, it's set to false. Okay, so that seems sort of strange. Why did the package not continue executing after that task failed? Because it says fail the package on failure, false, and yet the package failed at that point. Well, it's because we used a success precedence constraint to connect that task to the next task in line, this state 4 script task. Had I used a completion or a failure constraint instead, the package would have continued executing. So you can play with that and see how configuring precedence constraints affect how and whether a package fails based on various kinds of errors. Okay, now I'm going to change the package configuration to use checkpoints. So I need to make sure I've stopped execution here, and I need to click and be outside of any tasks. So I just clicked outside of any tasks in the control flow designer. Then I go over to the properties window here, and I need to go to the checkpoint, find the checkpoint properties there, and I need to specify a checkpoint file name. So I'll use the ellipsis button, which opens up the Select File dialog box. So I'm going to put this in the same directory as the project, just so it's a little bit easier to find. And I'm going to name this CP test for checkpoint test. And it's an XML file, so I'll call it what it is, and select Open, and that sets that property. Next I need to change the checkpoint usage property here. Notice that it's set to the default of never, so that's why checkpoints haven't kicked in so far. I didn't have a file name defined anyway. But in this case, I want to change it to if exists. And again, that's the most common option that you'll want to use when you're using checkpoints. Okay, and then one other thing I want to do for good measure is select the execute SQL task there and change this fail package on failure to true, just to explicitly cause the package to fail on that task, which is something I'd commonly want to do because now the package is going to fail no matter what this precedence constraint is configured as. And so that's a situation that I want, particularly when using checkpoints. And I can do that on multiple tasks. If there's multiple tasks that are causing me fits and problems, and I want to fail the package explicitly on those tasks. Okay, I'll once again save my changes, even though they're saved when I run the package. So I'll start at the execution again. So there's state 1, starting over at the beginning, state 2, state 3, and the package fails. Okay, and it ended in the expected place again. So I'll end execution. And now all that's changed at this point is that the package created a checkpoint file. So I can go take a look at that and do File, Open File, and there's I'm in my checkpoints directory. I'm actually one low. Uh-oh, not seeing it. Did I put it in the right place? Okay, I'm not seeing my checkpoints file. I've apparently done something wrong. Let me look at my package properties. So the checkpoint is at sample files, checkpoints. See, sample files, checkpoints. Make sure I'm going there. Right there. Yep, that's the right place. And right there's what I did wrong. I didn't change save checkpoints from false to true. So I'll go ahead and do that and start over. There's state 1, state 2, state 3. So we started over from the beginning again because there was no checkpoint file. And the package fails. Okay, and the good news is that I can see in the output window here that it is in fact using the checkpoints file. So it's starting to save them at that particular location, and then it gives me a line each time some information was written to the checkpoint file. Okay, so I just missed that I hadn't turned on checkpoints essentially. Okay, so now I should be able to go into File Open, into what directory there, and there's the checkpoint file. Okay, thank heavens. All right, so there's the contents of the checkpoint file. I'm going to do a Control KD to format the XML, make it a little bit easier to read. And there you can see the contents of the checkpoint file. So the root element is DTS checkpoint. It's got a name there of DTS, and it includes the package ID that I mentioned that's included. And then it has a list of the variables and namespace user, its state, and then the variable value at the point the package failed was 3. So the first 3 script tasks had executed, and so the value was 3. Okay, so this is a very simple checkpoint file. I'm only tracking a single variable as well as other information about the package that's associated with this checkpoint file. But in a more sophisticated package with a lot more going on, a lot more state information, more variables, and so forth, then there would be a lot more information that's stored here in order that integration services can restore the state of the package at the point of failure. And it also records which of the different tasks had already executed. Okay, so I'll close that file. Not going to save the formatting changes. And I'll fix the error. Not really an error, but I'll fix the error so that the package executes successfully. So I'll change this to select 1 divided by 1. That hopefully will succeed. And then I'll execute the package again. Notice what happened. I didn't get the dialog box with state 1. I didn't get the dialog box with state 2. I didn't get the dialog box with state 3 because those first 3 tasks did not execute. The first task that executed was the execute SQL task, and it divided by 0. Then execution continued on, as you can see the execute SQL task succeeded. Execution continued on to the state 4 script task, and now I'm getting the dialog box for state 4. Go through that. Now state 5, which is the last one, and the package executed successfully. And notice too that these last 3 tasks got success icons because they're the ones that executed. These got no icons at all because they didn't execute. The checkpoint started execution here and continued with the rest of the data flow. All right, I'll end execution again. And once again, I'll go and look to open that checkpoint file. And notice that the file no longer exists. And the reason is because even though the package continued recording checkpoints as the rest of the package executed, these other tasks executed, the package completed successfully and integration services removed the checkpoint file. So the next time that I run this package, it'll start over from the beginning because there's no saved checkpoint information.